to our 2-6 multivariable equations video lesson. Go ahead and put your name in that top right hand corner and today's date. And remember guys, you can push pause anytime you need to, anytime I go too fast. So if you need more time to write down your title and stuff, you hit pause now. Alright, our learning targets for today is that I can solve an equation for more than one variable for a given variable, and I can solve for a missing variable in a formula. Okay. So our learning targets are that we can solve an equation with more than one variable for a given variable, and I can solve for a missing variable in a formula. So first things first, our literal equations are equations with more than one variables. Alright, now as far as it goes, a formula that we see often are just that they are equations with more than one variable. So they are literal equations. Used to solve for specific values. And one of the most common ones like we see with our formulas are like your area formula for a rectangle equals length times width. You have your perimeter formula, your P equals twice the length plus twice the width. All of those are formulas because they solve for something in particular. Okay. Now, we look at how we're going to solve these. So once again, we're going to solve by isolating the variable. So when we isolate the variable, that means we have to get it by itself, get it all alone. And we do that by performing inverse operations or opposite operations. To the variable. There you go. There we go. And that gets us through our notes for this set. Now we're going to dive right into the examples. So example 1. We're given 3x plus 2y equals 7z, and we're asked to solve for x. So one of the first things I always like to do with these is to locate my variable that I'm given. So I'm asked to solve for x. So here's x on the left side of my equal sign. Now the next thing to do is to ask yourself what's happening to x. So he right now is being multiplied by 3 and added to 2y. So if you think about our rules for equations, we have to get rid of what's happening farthest away from our variable. So that means my 2y is farther away from the variable there on the left side. So he's going to come over here. So we end up with 3x. And we're going to move our 2y equals 7z. And if our positive 2y comes over here, he becomes a minus 2y. Now at this step right here, we have to stop and ask ourselves, can I do 7z minus 2y? And that's no, we cannot combine it. So, not like terms. So we cannot do anything with that right side of the equal sign. We're just going to have to leave it alone. Now we're still focused on our x. So now what's happening to x? If he's side by side with that 3, that means he's being multiplied. So the opposite operation for that one would be to divide. So we're going to divide both sides by 3. So now this right side, 7z minus 2y cannot be divided by 3 because they cannot be divided by 3 evenly. So our answer then should be x equals 7z minus 2y all over 3. So if you notice with this literal equation, we go through all the steps that we're used to doing. It was a two-step equation. We transposed, and then we divided, but nothing reduced. And that's how literal equations work. So for today, we're going to go through all the steps we would normally go through to solve an equation. The biggest difference is it's just not going to simplify. Okay, for our next example, we scroll down here to example 2. We have V equals 43 pi u 2w. And if you notice, all of these guys here are side by side by side by side. So when we're asked to solve for w, first thing we got to do is find where w is. So there's a w. And if you look, that's the only w we have. And since everybody here is side by side by side, that means they're all being multiplied. So we're going to divide everybody here by what we don't need. So I want to keep my w, so that means I need to get rid of my 43 pi u2. So I'm going to do the same thing over here, 43 pi first, 43 pi u2. So over here, your 43's cancel, your pi's cancel, your u's cancel, your 2's cancel. With v over 43 pi u2. And equals, the only guy left over here is w. And once again, we go through the motions. We do the inverse operation of seeing if everybody's multiplying and dividing everybody. So with that being said, that's our final answer. We get v over 43 pi u2 equals w. I think it's supposed to be u squared. I think when I copied it wrong. Alright, down here at 3, we're asked to solve for t. So now, first things first, we have to locate t in our equation. So there's t. And now we have to get rid of who's farthest away from him to get t by itself. So over here on this left side of our equal sign, we have r and a, and then it's subtracting our 3tb. So to get t by itself, the first thing we got to do is get rid of who's farthest away from t on this left side. And that would be our ra. So we're going to transpose him over there. So I'm going to keep my negative 3tb equals 2. And now my ra comes over here to become a minus ra. Now same thing. We focus on t. What's happening to him? He's being multiplied by negative 3 and by b. So to undo that multiplication, we have to divide both sides by negative 3b. Negative 3b. Okay, now our negative 3's cancel. Our b's cancel. And we're left with t equals. And then this whole thing doesn't reduce. We're left with 2 minus ra all over negative 3b. There you go. Sorry to barely get it to fit there, but we did, so we're all good. And now, our example 4 is way up here at the top, so make sure you got example 3 done. So the same way as the first one. We first had to transpose, then we had to divide. This time we had to divide more than one thing. We had to divide 2. So transpose our ra divided by negative 3b, and we're all set. Alright, so example 4, we're asked to solve for b. So in order to solve for b, we need to reduce it. So I have ax, sorry about that, ax first. And now if you look here, I have to distribute that negative 3 to my parenthesis. So we'll get negative 3 times b and get negative 3b. We'll get negative 3 times a negative cx, which gives us a positive 3cx equals dx. There we go. So we have successfully reduced that left side of our equal sign. And now if you look, he has an ax. He's a 3b. He's a 3cx. None of these have identical variables, so we cannot combine them. So that's as far as we can go, is just distribute. Now remember, we're still asked to solve for b. So if I find my b right here, we have to get rid of who's on the same side with our b and who's farthest away. So I have ax, it's being subtracted from it. I have 3cx, which is being added to it. And because both of these guys are being added and subtracted with our 3b, we can go ahead and transpose those. So I'm going to take my positive ax over there and my positive 3cx over to the right side as well. So I'm going to be left with a negative 3b on the left equals dx drops down, and now my positive ax becomes a negative ax my plus 3cx becomes a minus 3cx. And that's as far as we can go because he has a D, he has an A, he has a C. They're not like terms. They don't all have exactly the same variables. And now to solve for B, the last thing we're going to do is divide everybody here by negative 3. Negative 3. Negative 3's cancel, and B equals. And same way as before, we've transposed, we've divided, but none of it reduces. We're left with dx minus AC minus 3cx all over negative 3. And we're good. Alright, so now, example 5. We have x minus ay all over y plus b equals c over d. We're asked to solve for x. So right here's our x, but if you notice, our x in this one is in a ratio, it's in a fraction, and then our c over d is also another fraction, another ratio. So when they're set equal to each other, we can actually go ahead and cross multiply this. So I'm going to do my ax minus 2y, maybe it's ay, I think I said ay, minus ay times d. So, remember from our steps, we're going to have to keep that in parentheses, my x minus ay, and that's because they're grouped together because they're that numerator. And I'm going to do my c times y plus b, so equals c times y plus b. Remember that equal sign always just drops down there in the center. And we're good. So now we're going to distribute. So d times x is dx. D times ay is a minus a dy. Remember, we always like to keep those variables in alphabetical order. C times y is cy. And then c times b is cb, or bc, I'm sorry. There you go. Now, we're still asked to solve for x. So now that I've kind of simplified it down, let's focus on where x is. X is on the left side. He is being multiplied by d. He's subtracting a dy. So now we got to get rid of who's farthest away here on this left side. And that would be my minus a dy. We'll take over there and make it a plus. I get dx equals cy plus bc. And now we're going to do our plus a dy. Now our last step to solve for x is to say if they're side by side, they're being multiplied, so we're going to divide both sides by d. Now d's cancel, and for this one where it's really large, we're just going to do this number. We say x equals, none of that reduces, cy plus bc plus ad all over d. There we go. We have one last one here, example 6. And this one's one of my favorite ones because it is a true formula. This is your perimeter formula. So, first thing we got to do is say we're solving for L. So we got to locate L in this equation. So there's my L. And he's on the right side this time. So if I'm going to solve for my L, who on the right side do I need to get rid of first? He's right beside of the 2. And he's adding 2w. So I take my plus 2w and say he's farther away. So we take him to the other side and make him a minus. So we'll get p minus 2w equals 2l. Now at this step, remember we're still solving for L, so look at this right side. If 2 and L are side by side, they're being multiplied, so we divide both sides by 2. 2's cancel on the right side, and p minus 2w over 2 doesn't reduce. That just is our answer, and we're all good. And that finishes up for our multivariable equations, or aka literal equations. If you need any help or have any questions, let me know. You're good to go ahead and start your practice work. Thanks.